So chain rule is the last of the rules in finding derivatives. And they're used on functions that are basically composites of each other. For example, if you look at f of x equals 2 minus x cubed, that's actually a composite where one function is x cubed and the other function is 2 minus x. Do you see how the composite of f of g of x is created to get this function right here? Remember, you take g of x and you plug it in to x cubed, and that's how you get the function. So to find the derivative when you have a composite, you basically take the derivative of the outside, the derivative of the outside function times the inside times the derivative of the inside. So if we take this first example, the derivative of 2 minus x cubed, you take the derivative of f of x, which would be 3x squared. But instead of writing in x, I'm going to write in exactly what I plugged in for x, which was an x minus, 2 minus x. And now I multiply it by the derivative of g, which is just -1. Multiplying them together, I get a -3, 2 minus x squared. And that is the derivative of that function. Okay, so again, you take the derivative of the first function, which was x cubed, so it's 3x squared, and then you take the derivative of the inside, which was 2 minus x, or -1. And that's chain rule. So we're going to look at a lot more examples. Okay, here, let's see if we can pull out the two functions. You know, actually, I'm going to label them u of x and v of x so we can kind of fit the formula. U of x is going to be 4x to the 6. V of x is 5x cubed plus 2. Think about it. I have to put v inside of u, so I have to put the 5x cubed plus 2 inside of the x into 4x to the 6 to get the composite. Okay? So I take the derivative of u.
Ashley Schwartz, if you're still on campus, could you see Jenna, please? Thank you.
Okay? You take the derivative of u, and then you put v on the inside. Think about it from the formula. And now you take the derivative of v, which is going to be 15x squared. Multiplying it together, you get 360x squared. 5x cubed plus 2 to the 5th. No need to try to expand that or anything. It just becomes too complicated. All right? Let's look at C. I want to jump down since I ran out of space up there. I have my v of x and my u of x. All right? I'm plugging in x squared into my e to the x function, okay? So u is that outside function. V is what I'm plugging into u. You see how you get the composite? So now you take the derivative of u. The derivative of e to the x is just e to the x. But instead of writing x, I'm going to write in whatever v was. And now I multiply it by the derivative of v, which is 2x. Combined together, I get 2x e to the x squared. And that is my derivative. All right? Let's look at another one. I'm going to thin out my pen so you can see it here. My use of the x. That big function is the square root of x. V is going to be 4x squared plus 1. The derivative of the square root of x is 1 over 2 x to the -1/2. But instead of writing x, you guessed it, I'm going to write x 4x squared plus 1. Then I'm going to multiply it by the derivative of v, which is 8x. Combining like terms, not combining like terms, multiplying, I'm sorry. I'm going to get 4x, because half of 8x is 4x, over 4x squared plus 1 to the 1/2, because I'm going to make that exponent positive. The last one down here, u of x is 1 over x v of x is x squared plus 1. What you should try to do is, try to figure these out yourself before I actually do them, so that way you can see it. See if you can at least figure out what the two functions are. So the derivative of e to the x is ln. Oh, I'm sorry. That was a mistake. The derivative of u would be negative 1/2 x to the negative 2. But instead of writing x, what am I going to write? You guessed it, x squared plus 1. And then I multiply that by the derivative of v, which is 2x. So multiplying together, I'm going to have a negative x over x squared plus 1 raised to the positive 1/2. Now, yes, you could write these as radicals, that's fine. But if you feel more comfortable, you can leave it just with the rational exponent. And that's chain rule. Here are a few problems that involve some of our other rules like product and quotient mixed in with chain rule. If you look at E, this is product rule. You'll have x times the square root of 1 minus x squared. And remember, product rule says the first times the derivative of the second plus the second times the derivative of the first. So as we apply the product rule, remember it's the first times the derivative of the second.
Carlita Daughtry, please come to the front office. Carlita Daughtry, please come to the front office.
Plus the second times the derivative of the first. The derivative of x is 1. Now I left that blank for a reason because the derivative of the second is going to use chain rule. Okay? So I'm going to do the chain rule over here. My u of x function is, my u of x function is the square root of x. My v of x function would be 1 minus x squared. So remember, to take the derivative using chain rule, you take the derivative of u, which would be 1/2 x to the negative 1/2. But again, instead of writing x, you're going to write in v times the derivative of v, which would be negative 2x. So when you multiply that and simplify, you're going to get negative x over 1 minus x squared raised to the 1/2. Because remember, we want positive exponents here. And then you multiply. You get a negative x squared all over. I'm going to write this one as a root only because in this problem, I already have a square root. And then I can leave it like this. This would be my derivative. I could try to get a common denominator and everything, and that would be fine. But this would also be acceptable as well. Look at G. Okay? You have another chain rule. Your first function, u of x, is ln of x. Your v of x would be x over x squared plus 1. So when I do my derivative using chain rule, the derivative of ln of x is 1 over x, but I'm not going to put an x, I'm going to put my v. And I times it by the derivative of v. Now if you look at the derivative of v, I'm going to have to use quotient rule here. Low d high minus high d low all over low, low. Okay? And now it's just a matter of multiplying and simplifying. And so what I'll have, multiplying straight across and combining in the same step, I'm going to have negative x squared plus 1, because this is a 2x squared. This would be the x squared plus 1. So when I subtract them, that's how I get the negative x squared plus 1. All over, when I multiply my denominators together, 1x squared plus 1 is going to cancel out with this one here, leaving me with x times x squared plus 1. I can see that I'm not going to be able to do anything from this point, even though these look the same, the top and the bottom thing is that this is a negative, which means that if I try to factor out a negative, this becomes a minus. So this is my derivative for G. Mind you, pause it if you need to, okay? Take notes. If you have questions, the last one, I'm gonna look at F now that I've cleaned off my board, okay? Chain rule again, my U function is E x to the fourth. My V would be 2, 3x minus 1. Do not distribute. The reason why, you have 3x minus 1 raised to the fourth power. Do not distribute. Only the 3x minus 1 is being raised to the fourth power. So, you got like chain rule, this is like they got a lot going on here, okay? So, well actually, let's change this up. I can actually make this a little bit easier for me, okay? I'm actually going to make my U function E to the 2x to the fourth, and my V 3x minus 1. That might make it a little bit easier, because when I plug in, you see how I can do the composite. So the derivative of U, okay, that's another chain rule there. So E to the 2x to the 4, because I take the derivative of E to the x, and I'm going to multiply it by the derivative of the top, which is going to be ax cubed. So that's my derivative. But instead of writing the x here, I'm going to write in my v. So it's going to be E2 to the 3x minus 1 times 8x cubed times the derivative of v, which would be just 3. So when I multiply, I'm going to get 24 E, or actually, I should put x first. X cubed, E to the 2, 3x minus 1. To the fourth power. And that's my derivative. It comes with practice. I'm going to also put up another video just in case you guys are having some difficulty. And of course, bring your questions to me on Wednesday.